Hello and welcome Nordi Anglia, and thank you for joining us today for our MIT abstract on physics with MIT physics graduate student Makinde Ogunnaike. I'm your host, Fatima Hussein, and I'm a PhD student at MIT studying ancient Earth. Now, before we begin, I'd like to cue our listeners into what an abstract actually is. An abstract is simply a snapshot or a summary of a greater work of research or writing, and with this series, MIT Abstracts, we're bringing these abstracts of inspiring MIT experts straight to you wherever you are around the world. And I know we have a lot of classrooms tuning in today, so welcome. So now I would like to introduce Makinde, who's going to tell us all about his cool work. Welcome.
Well, thank you, Fatima, for the introduction. So today I want to tell you all a little story about physics, which is the fundamental science. It's the science of matter and energy, of all the things in the world that you can touch and see and interact with. But it's actually a lot more than that. It's kind of a story or an experience. Well, let me tell you a little bit about what I mean. So physics is the study of matter, all this stuff around us. But really, it's all these things are kind of made up of dreams. And what I mean by that is kind of funny. So have you ever woken up from a dream that you once had and tried to figure out why you had it, how everything kind of came together? Try to pick out the memories and feelings you had from the past that kind of wove together that really crazy experience. Physics is actually kind of the opposite of that. It's, you look around you, you have lots of experiences, you see lots of things, you have memories, and then you try to tell a story about it. You try to come up with some way that everything is connected. But, that can actually be kind of tough. Like I said, physics is actually the study of things that are fundamental. They're basic building blocks. They're key characters in all of your stories. And thankfully, in physics, we're really, really good at identifying who those key players are. In fact, we've actually figured out pretty much all of the different little particles, the tiniest bits of matter in the universe. We've figured out what they are. And we've given them some pretty fun names like up, down, bottom, top, and maybe my favorite name, strange. But, just giving them a name doesn't really finish the story. If you actually want to know what's going on, you have to explain how they interact with things, how they construct the big narrative that is the story of physics. So let's take a look at maybe one of the more familiar ones, the electron. So what is an electron? If you were to ask a physicist, it would be a list of properties, how much it weighs, how quickly it spins, how much charge it has. And charge is kind of a thing that tells you how much it pushes away other electrons and pulls other positive charged particles, like protons or things in an atom, towards it. But if you just tell people all those lists of properties, you won't really get a feel for what an electron is. The picture at the beginning, or this thing on the right, you see the electron, this little gray blob, going in a circle around something else. It's pulled in by something with an opposite charge. It likes to orbit and hang around with that person. And if you give it a jolt, you let it go free, then it can go on a crazy rampage and turn into lightning, like you see on the left. So when I was a kid, I actually enjoyed this so much, identifying the little basic building blocks and trying to construct up a story like physics, that I kind of tried to do the same thing for myself. So, I tried to ask, who am I? And I tried to piece it apart like an electron. So I'm Nigerian. I like soccer a lot. And I study physics at MIT. But just like the electron, if not even more, you wouldn't get a really good feel for me if that's all I told you. You can measure the mass of the electron, but how do you really measure me? How do you describe who I am? Well, the best thing is to use the language of dreams, to penetrate into what the actual story is. And that's through poetry, you know, the very language that dreams are kind of made of. So I'd have to tell you stories about who I am and what I do, a list of what ifs, and if I was in different situations. Um, that can be kind of difficult, especially when you get to deeper aspects of who I am. So, how do you share your dream? How do you tell people about the deepest aspects of who you are, or the most complicated, deep, tiny aspects of what physics is? Well, in physics, we like to use math. Math is really nice because it's objective. Everyone can agree that 2 plus 2 is 4 all the time. But even then, sharing that dream, sharing that description of physics can be hard, because if you try to describe something, you ask different questions of it, sometimes you get different answers. So let me give you an idea of what I mean. If I want to talk about our little buddy, the electron, well, if I want to ask a certain question, it may look some kind of way. If I ask a different question, it may look different. So let's pretend right now that our buddy, the electron, is this little bouncing bit of water. If I were able to freeze this, which because I'm not good with technology, I can't, but if I could freeze this, and then I asked you, where is the electron? You'd probably say, oh, it's that little blob on top of everything. But if I were to freeze it again and say, where's the electron going? Well, if you just look at the blob, you have no idea. But if you look at the wave underneath, then yeah, you can say it's rippling off in that direction. So the electron's going there. And maybe the wave is actually what the electron is. So, is one right? Kind of. They're kind of both right. Depends how you look at the thing. It could be that little blob or particle looking thing, or it could be the wave. In some sense, both are actually true. But if you stick to just the math, you don't have any idea what the real substance of the thing is. So, what about trying to figure it out as a person? Again, I'm going to tell you a little bit about my life, which was my favorite birthday party. Kind of explain this weird duality, these two things existing at the same time. So my favorite birthday party when I was a kid was Star Wars themed, as is appropriate for today. May the 4th be with all of you. When I was a kid, I had this great birthday party where all of my friends had lightsabers and they were chasing around in a giant battle. So what I saw was a bunch of, little kids with colorful little sticks, swinging them all through the air and pretending to throw each other around using the force. But that would only give you a tiny picture of what actually happened that day. If that was all that it was, it wouldn't have stuck in my memory for so long, and it wouldn't have been so memorable. It was so incredible because when I was experiencing it, what I felt was that I was Obi-Wan encountering Darth Vader for the first time. I felt as though I could use the Force, and I was wielding this giant lightsaber that could cut through almost anything. And yeah, that was absolutely true and is true today. I still remember and I still feel that. So, is one really true? Was it only that picture of a bunch of little kids running around? If I tell you that, you won't get the feeling that I had. If I tell you the feeling of me actually being Obi-Wan, you won't realize it was a bunch of little kids playing together. They're both kind of true. And you kind of need poetry, the language of dreams, to sew together these almost logically at odds descriptions of things. But like I said, sharing dreams can be a bit hard. And they get particularly hard when you're not just sharing yours, but you're sharing a whole group. So my own research in physics isn't just about one electron, it's about what happens when you get a whole bunch of them together. And, just like with people, things are a lot more fun with friends. Electrons in particular, they look really funny when they get together. Sometimes they can act very stately and be very, very cautious around each other and dance around in these little ballroom circles. Sometimes they can be really, really close and play together in all sorts of weird ways and make up, house rules. They can start playing tag with each other, and because maybe they just want to have some more fun and they got bored, they make up a rule that instead of tagging and transferring the person who's it, if you tag, you and your best friend are both it, but now you have to run around with just one arm to play. Just cause, make things more fun. Um, Electrons, once they get together, if they're really, really close, they can do all sorts of crazy things. And you have to dream pretty deep to figure out what they're up to. In fact, it can be so difficult that actually talking about electrons is really hard because they're so tightly knit, it's hard to pull them apart. So we actually describe things called quasi-particles, which is kind of a long name for kind of particles. It's the things you actually see, even if they're not the actual electrons themselves. When things are really, really strong, it's tough to discern what electron is what. Sometimes it can just be, if you push an electron super hard, one bulges out and messes with the people around it. And so you look at maybe not the electron, but the bulge in the group. Sometimes electrons are really, really tight with all their friends and they share their properties. I told you electrons have charge and they have spin, they rotate. And sometimes when electrons are really close with their friends, it looks like they give their charge to some friends on one side and their spin to some friends on the other side. And they don't really care about keeping them together anymore. It's all about sharing, which is something you would never expect a single electron to do. It's only really possible when it has friends around. And it's only something that can kind of make sense when you keep trying to figure out a dream that puts all of this stuff together. And you keep looking for the right language, the right poetry to describe what physics actually is. So my one message to all of you is to keep dreaming. You all might be the ones to write the next chapter in the story of the electron, or maybe even the strange quark. So, thank you.
Fantastic. Thank you. I guess we can jump right into the Q&A now. And I have to ask a beginning question. So I think you broke up just really briefly when you were describing lightning and electrons. Can you just remind us what's going on with electrons when we see lightning, during those big thunderstorms?
Sure. So when you see lightning in a thunderstorm, what happens is you get electrons that normally are, tightly bound, or they're orbiting some proton, something with a different charge, kind of minding their own business in their own little house. And then they get a bit of a jolt. One of them gets kicked out, and then they start skipping from one atom, from one little house to another, until a whole bunch of them just go running wild. They skirt across the sky, and when they move back and forth, they actually let out light, which is what you see as the lightning.
Wow. And can you tell us whether that relates to fireworks at all? Is that a similar concept?
It's pretty similar. The electrons kind of get jolted, or they kind of get pushed out of their comfortable little seat or home in an electron. And then when they jostle around, when they try to find some place to settle down again, they let out light. With fireworks, we just kind of control it. We say that we want the light to be in a certain place instead of with lightning, where it kind of just runs around wherever it wants.
That is super cool. Oh, we have a really nice question from a Northern Anglia student, and they're wondering, what's your favorite poem that you've ever written, and is it about physics?
Ooh, that is very tough. Actually, I don't think so. I think my favorite poem ever written was one time, admittedly after a long day of physics, but I actually just went to sit by a river, and I noticed the waves on the river, um, which maybe they were inspired by particles acting like waves. Um, but it just felt like, memories and parts of me were fading or slipping away like waves on the water. Um, and I just wrote a poem on the spot. That's probably my favorite, though I do have a lot of poems about physics.
And could you tell us a little more about how you keep up with poetry? I mean, we're both graduate students at MIT. We are doing research, what feels like nonstop. How do you still find the time to do poetry, and what does that look like for you?
Well, a lot of that for me is reading poetry. Writing it often, I feel like, it comes with being within it, or being immersed in anything. If you really love something, you want to be a part of it and engage. And for me, that usually looks like, when I wake up in the morning, just like today, I'll have a cup of tea and then I'll read a poem. And usually it will inspire something. And maybe if I get a free moment, or if I'm really tired at the end of the day, kind of like with this, my favorite poem, then I'll just jot something down. Um, and sometimes I'll share it with people. Sometimes I'll just keep it as one of my favorites for myself.
Oh, that's really lovely. And now we have a question from Rachel. And Rachel's wondering, why did you choose to study physics, and why did you choose MIT as a place to study it?
Hmm. Well, I think I chose physics because, like I said in the beginning, it's the science of the fundamental. Um, so I wanted to see what was the most basic aspect of reality, really. And physics kind of promised to get at all those most basic things. So I might not be able to understand the most complicated aspect of, social interactions, but physics does a nice job of telling you what maybe the most essential bits of things are. Um, and when I was a kid, I kind of thought that if I learned physics well enough, I could understand anything from it. Um, I might not think that right now, but I still kind of love the aspect of, in principle, you can explain almost anything in the physical universe using physics. And I chose MIT because there are just so many people who are like me, who are really, really excited about it, and who spend so much time thinking about it in all sorts of different ways. Maybe not everyone loves poetry as much as I do, but there are all sorts of people who think about it in different, crazy, and fun ways.
I mean, I think that's a really nice segue into the next question I wanted to ask you. So, you know, you're taking a a research approach that helps you explain the universe and everything that we observe and see. And in poetry, is it fair to say you're doing the same thing using those words? So you're using different language than physics, but you're using, words that you and I might use when we're just talking to each other casually. So is it fair to say that with both of these hobbies and interests in your life, your goal is to really just explain the universe?
Yeah, I think so. I mean, the nice thing is, physics and poetry are kind of dual languages, to describe different aspects of reality. Like I said, when I had my favorite birthday party, I could tell you all the things with, all the physical details of what I saw and felt. And physics is actually really great at that. Like I said, it can't fully be that. You always need a bit of dreaming just to make physics make sense. But poetry does a really great job of capturing that interior experience, of capturing the mindset, the feeling, the actual like ethereal dream that you feel when you experience the rest of the world. And you can do that by kind of piecing things apart or getting the fundamentals, either in the poetic expression, the imagery, or the essentials of who you are. But yeah, I think, at least for me, both are kind of ways of trying to get at the roots of what reality is.
So now I wonder if you're willing to nerd out with me for a second, since we're both nerds at MIT. Can you tell us, throughout your physics education, have you learned anything in physics that's just like blown your mind?
Um, I mean, I would be lying if I said that didn't happen almost every year. Um, but let me try to think of one of my favorites. So when I took a class on general relativity, which is a subject that deals with space and time and how they kind of work together, um, I learned something really, really funny about black holes, which are a subject which have all sorts of crazy things. Um, but one of the weirdest things was that if you're really, really far from a black hole, so far enough you don't feel like it's pulling on you at all, um, and you look at something or someone falling in, because black holes don't just pull you in, they actually affect the rate at which time clicks for you. It changes how quick time moves on your clock. If you look at something falling into a black hole, from your perspective, if you're far enough away, it actually never falls in. It just looks like it gets closer and closer and closer and closer and closer and closer and closer. And if you're far enough away, it just seems like it's always just about to fall in, but never quite there. But from the perspective of the thing falling in, nothing changed. It just went in. It's just there's such a radical difference in how you perceive time that, for all intents and purposes, you actually never see the event that actually has to take place.
So what you're saying is if the students on this call study enough physics and take a class like that, they get to figure out how time can get really funny and
Oh,
really weird.
mm-hmm.
Interesting. That's not something we think about every day. We take a second or a minute or an hour for granted. But wow, when you're talking about these kinds of things happening out there in the universe in places we don't even understand, things are totally different. And physics can help explain that.
Yeah, exactly.
Wow. Oh my goodness. So we have a question from a Nord Anglia student, and they're wondering, did you ever have a teacher that inspired you to go into physics? Or, how did you first get introduced and say, okay, this is how I'm going to explain the universe?
So I think I might actually have three different people I really would have to thank for getting into physics. Um, the first would be my elder brother, who, when I was a little kid, taught me all the parts of the atom, down to the electrons, protons, neutrons, and inside protons and neutrons, there are some of these quarks that I showed you earlier, up and down, and even taught me a little bit about how the electron orbits in the atom. Needless to say, I was a very, very annoying kindergartner who wanted to share all of this stuff with everyone. But yeah, that kind of started me off on a path that was hard to escape from which it was hard to escape. After that, I had a really, really incredible physics teacher who, anytime I was curious about something, he would look it up or get me a book. Um, and even when I had taken lots of the classes that were officially offered, he just kind of got me a book on classes in quantum mechanics and special relativity on subjects I hadn't learned about. And while he was teaching his official class, he gave me these books and some things to read about in another classroom and said, if you're curious, you should learn, and we'll talk about it after. So he just wanted me to explore and figure out what was going on in the universe. And that experience, being very, very different from filling out sheets or trying to finish problem sets, or just answering questions that someone else had asked, really made me fall in love with it because, yeah, like I said, it's about kind of trying to find a dream that puts everything together. And it's really, really hard to describe a dream if you're always trying to picture someone else's image of something and not your own. Um, and probably the last person is someone that I met as an undergraduate who I would ask him lots of dumb questions about how to figure something out or how to solve a problem. And he would usually turn those questions back on me and make me try to think about how everything fit together, and sometimes talk about completely different subjects and show me how things I thought were completely unrelated were actually very, very closely wed. So yeah, I've been very lucky to have lots of teachers who helped me out.
I think that's really powerful, and I want to encourage North Anglia students, reach out to your teacher, things that you find interesting for sure, because you might get these similar opportunities to learn, like Makinde did, and like I definitely did. I used to love reading, and I talked to Makinde right before this about our shared love for poetry, and I used to ask my English teachers when I was an elementary student and middle school student, and I would say, oh, I really like this poem that we read in class. Are there more like it that I can read? And they would give me little books to take home with me to read, or send me links on my school email address. So that really set me off on my own path. And same with geology. So I think that's really powerful. We have a question from, I think, a budding physicist in our audience. Okay, so we have a North Anglia student who's wondering if you could tell us a little more about what happens if many electrons interact with many other electrons.
Oh, well, that's actually basically everything that I do in my research. So there are a ton of different things that can happen when lots of electrons interact with each other. Um, Normally, electrons don't actually like to be together because they have a negative charge. And the way charge works is charges that are similar, so two negative charges, hate to be really close and like to fly apart. You need a positive charge, something of the opposite side, that actually pulls on its opposite and keeps them together. So normally, electrons like to live in atoms where there's a lot of positive charge in the center, and then the electrons kind of whiz around on the outside. But when you put lots of materials together, when you put lots of atoms together, you have lots of positive charges, and then you have electrons that kind of whiz around between them. Um, and if you put those things really, really close together, and you cool things down really, really low in temperature, which basically means that the electrons are whizzing around way slower. Sometimes, like I said, the electrons can pair up and dance together. And then when they dance together, sometimes instead of getting weird electricity like lightning, you can get something called superconductivity, which is when you get electricity but no resistance. Like if you've ever plugged something in and you felt it heat up a little bit, that wouldn't happen because there's no extra heat. The electrons are kind of dancing so much in sync that they don't really mind there being other positive charges or electrons around each other. They're kind of all content with just each other. Um, that's one example of what can happen when you get lots and lots of electrons together.
Oh, wow. Okay, so that leaves me thinking I'm going to test this out 3 ways. I have 3 things to try after this, and I think I'm going to invite North Anglia students to do that with me. I'm going to take 2 magnets and I'm going to try to push them together, see what happens. And if you're correct, they will not like that. And the electrons will be like, get away from me, get away from each other. I'm happy with my own friends on this magnet. And then if I take my magnet and try to put it on my fridge, it should stick because the electrons really do want to be there and they want to be friends. And then the last thing I'm going to do is next time I plug in my laptop charger or my phone charger, I'm going to feel the charger very gently and see if it heats up, to see if I'm getting that resistance you're talking about or that heat. And then I'll imagine, wow, if I cooled this down really, really, really cold, colder than I can do myself, then I would never feel that in the first place. Wow. Lots of things to try. I think, yeah, you're already explaining the universe to us right here, right now. We have a question from another North Anglia student, and I think they're interested in something a little multidisciplinary. So they said, what other subjects do you like outside of physics? So you're doing physics and poetry, but they're wondering, what are you interested in outside of those 2 things?
Well, I actually really like philosophy. So I actually studied philosophy for a year before beginning my degree in physics, or my PhD. And I also really like the study of religion. So to me, all of these are kind of, again, just like secret different ways of trying to understand reality in different ways or from different levels. And yeah, I think they're all really, really interesting. Just if you study theology, you can try to understand either what God is to you or what it is for different people from different cultures or different perspectives. And oftentimes that even says something about how you understand physics yourself. or others, because that God or something that comes before the rest of the world um, can kind of describe what the world is and in what context it relates to humans or other things. And philosophy can be really nice because it kind of does a very similar thing. It tells you what things are, sometimes why they fit together and why they might be useful. Um, and on top of that, I also really like studying my own language and culture. I'm from the Yoruba tribe in Nigeria. And so I don't speak my native language too well, but I really love learning about it. And about my own people and lots of other African cultures and languages.
Wow, that's really wonderful. So if I'm getting this right, um, outside of physics and poetry, you enjoy learning about religion and philosophy, which are, all four of those are fields that either give us the framework to explain the universe or attempt to explain the universe. Is that right?
Yeah, pretty simple, man.
You are all about the universe, and I absolutely love it. That is so cool. So we have another question from a student who's wondering, how and when did you figure out that you could do both? How did you know you could do physics and poetry at the same time? Did these things start together, or when did they both come into your life?
Um, I mean, to be completely honest, it's hard to imagine living without one. Um, like I said, my brother taught me about physics when I was in kindergarten. So it's kind of hard for me to picture a world where I don't have physics, as you would see in the classroom, somewhere in my head. Um, and poetry is also something that, I heard whether I was paying attention or not since I was a little kid, whether it be in actual, like song lyrics, um, or in my brothers or parents reading some of their favorite poems. That was something that was always kind of present. Um, but also, I think even on a deeper level, it's kind of hard to imagine the world without either of them. The poetry's around you all the time. Sometimes even when you have a friend say something very profound or something that just sounds kind of lyrical, you hear and feel poetry. And heck, with physics, the world's around us. I'm still sensing things, and I try to figure out how they work. So even if I don't write down a mathematical model, I'm kind of still doing physics. So for me, the two were always kind of there, but it was never really clear that I could do both kind of academically or both kind of be wed in a career. Um, that's something that kind of just popped up here and there, and I was passionate about both. So um, yeah, it just kind of percolated up through the years. I don't know if there's a particular moment where I decided, yes, I can and will do both things at the same time.
Got it. Okay. And now we have a really highly thumbs up, so upvoted question from Relang. And Relang's wondering, can you share one of your poems with us? And we don't want to put you on the spot. I don't know if you even have one memorized, but if you don't, could you tell us, where could we read your work? Where could we find some of your poetry?
Ooh, I have not published much of my work. There's a little bit. There is one that's somewhere on MIT's website. It's a poem about some of my work. Um, and there may be some hidden in Harvard websites somewhere. Um, but I can see if I actually can find a poem. I'll see if I can find a poem about physics for y'all.
Oh,
Um,
okay.
because I do actually really like writing those things. Um, but those are often the ones that I keep to myself a little more.
Of
But it
course.
sounds like it'd be kind of fun for y'all. So why not?
Wow. While you're looking for that, I'm just getting so excited that we're going to have our first MIT abstract poetry reading.
Yeah, I'm guessing that's maybe not something that comes up every day.
Yeah, you'd be surprised. We haven't really gotten there yet. That is very, very cool. And I really like, while you're looking for that, I really like what you said about, these things just all coming together, and you weren't necessarily planning to do physics and poetry. It just kind of happened. Just like as I study for my PhD here at MIT and I study earth science, I didn't, really know that I was still going to be able to do these wonderful webinars with the students and work with Nord Anglia students and still write about my work and share it with people. So it is really lovely how sometimes the universe has a way of making things right. And I really do appreciate that.
Yeah.
We have a perfect MIT question from a Nord Anglia student, and they want to know, what's your favorite science movie?
Ooh, that is very difficult. What qualifies as a science movie? Because I mean, I love Star Wars more than I should, but I mean, it's probably not the most scientifically accurate portrayal of much of anything. I also really love Interstellar for the pictures of black holes and stuff. And none of you will remember or know much about this, but there's a movie 2001: A Space Odyssey, which is a very old, very classic movie, which is really, really cool, and kind of just a nice portrayal of space, and is also very, very trippy. So if you're either a film nerd, a science nerd, or just want it for the history or culture, then that's a fun one to check out, probably with a friend or so.
Oh, those are some really good recs. And you mentioned black holes when you were talking about the movie Interstellar. We have a Nord Anglia student who's wondering, do you study black holes as part of your work at all?
So I don't study black holes. I don't study them in my direct research. Some of the research that I do actually has to do or says something about black holes. You can relate some of it to it. But while I was studying philosophy for a year, I was actually in a seminar about black holes. So I learned quite a bit about them. And because of that, I've actually been mentoring an undergraduate every winter session, so in between different terms. And for the last 3 years, I've been teaching college freshmen about black holes and all the trippy things that they do.
Oh, that's really fun. And while you're still loading that up, we have another nice question from a Nord Anglia student that just came in, and they're wondering, do you have a favorite poet?
Ooh. I do. I doubt many of you will know him. The poet's name is Li Po. He's a Chinese poet from a very long time ago who writes a lot about lunar imagery, and has kind of, well, kind of fitting for this, very dreamy descriptions of the world, his life, and kind of, meditations in the universe. Now, if I could read Chinese, I'd probably love him even better. But I really appreciate his, his take on things. And I feel like they are kind of short snippets of a world that can't fully be captured in long descriptions is something that I've always really appreciated.
Oh my goodness, of course. Well, real quick before that, so you mentioned you were learning Nigerian, you were learning the language of your heritage. It sounds like you could learn Mandarin next if you have like some free time, I guess, so that you can read these poems.
I'll tell my advisor I need some time off to learn Mandarin.
Yeah, I'm sure that your advisor would take it really well.
All right. Well, here's a little poem I wrote called Metaphysics. Alone with my thoughts, my mind drifts through the natural world. God's thoughts made manifest. I look for time and space to ponder, but time and space twist and turn. endlessly entangled in a cosmic waltz. I squint, hoping to better observe, but matter itself quivers, coyly avoiding my pointed gaze. Words left wanting to describe normalized and renormalized so often, forms differentiated on paper fail to integrate a full life. Pondering projections of timeless truths, I wonder if I can honestly gauge whether it is the space-time and matter that fluctuate, or simply my mind's eye.
Wow, thank you so much for sharing that with us. That leaves me very contemplative. I'm getting very contemplative vibes from that. And speaking of contemplative, I think you've inspired a lot of people to contemplate the universe today. And a lot of students might pursue physics and even poetry or philosophy going further. And I wonder, could you give them any parting advice, skills that they should cultivate, or tell us about the qualities that folks who are good at physics tend to have?
Um, sure. So like I said, physics is written in the language of math, um, but that doesn't describe the full story. Most of what you'll study, if you end up just trying to do physics, will be like lots of the technical aspects. You do math, you solve problems and whatnot. Similarly, if you study poetry, a lot of times you'll study techniques and things and very famous people. But especially for physics and for poetry, I think the most important thing is to remember to be curious and ask, what if? You know, an electron isn't a list of properties, it's a list of stories. So if you can remain curious and you can ask, what if you can try to construct how things could be a little different, what things might look like if you tried to put them in a different environment, and you stick with that. You keep trying to find and understand and weave together a tighter story. That'll take you much, much further than reading lots of textbooks on one particular subject, on one particular technique. Yeah, it takes practice and time. And if you enjoy and you keep questioning, it'll feel like no time at all.
I really like that insight. And I think even I can continue to apply that as I pursue my own education. I know the Nord Anglia students can definitely do that for sure. And now I'd like to give a big thank you to the Nord Anglia Education MIT collaboration for making MIT abstracts in this wonderful series possible. And further, I'd like to thank Makinde for sharing his time, insights, contemplations, and his poem with us today. That was a first, and I think that's pretty unforgettable. So thank you so much, Makinde.
My pleasure.
All right. Well, we hope to see you soon on the next lineup of MIT abstracts, and we will see you next time. Goodbye, everyone.